guys, this is Maria Baranova, a Chemistry 120 SI leader, and today we'll be going over orbitals. As we know before, n is equal to a whole number 1 through 7. L is equal to a whole number as well, and that is n minus 1 all the way through 0. ML is actually equal to the positive and negative of L, and the spin, which is going to be ms, is a positive and negative 1/2. Okay, and we know every L value is going to be 0, 1, 2, and 3. Let's just go through that. And this one has an s orbital, this one has a p orbital, and this one has a d orbital, and 3 has an f. Okay, and what does this tell us? That s actually has only one orbital, and each orbital has a positive and negative spin, which means there's a electron going the positive way, and then there's an electron going negative way. So there's 2 electrons there. 1, 2. Okay, our p orbital has 3. Okay, so what does this tell us? That we can put 6 electrons in it. 1, 2, 3. And these like to be in opposite spins. So each orbital is going to be filled up before the second electron comes in. And D has 1, 2, 3, 4, 5 orbitals, which means after we put 2 electrons in each orbital, we know that that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And notice how I went with 1 electron in each orbital first, and then went back and put the second one in there. And we use the same concept for F, and if you followed, we've just been adding 2 orbitals to each one. So, as you might imagine, this has 7. 1, 2, 3, 4, 5, 6, 7. Okay, and what this means is I just put 1, 2, 3, 4, 5, 6, 7, and then going back, 8, 9, 10, 11, 12, 13, 14 electrons in this F. Okay, this is going to be very helpful, so I would jot this down if I was you. We'll start with 1s, 2s, 3s, 4s, 5s, 6s, and 7s. And go back up. We don't have one p orbital because we don't have the 0, or we don't have the 1l, because as we reviewed before, if n is equal to 2, which this is n, then all we can have is 1 and 0. And with 1, we can only have 0. So the only orbital in 1n is s. Okay? So 2p, 3p, 4p, 5p, 6p, 7p. Okay, and then we go back down, and we have 3d, 4d, 5d, and 6d. Okay, and we don't have a d orbital, as we repeated again. 2 minus 1 is 1. So we only have an sp. We cannot have a d orbital. And so forth, the law continues. Okay, this is 4f and 5f. And since we don't have elements that would fill up the next d orbital, or the next f, d, and f orbital, we just stop there. Okay, and how this comes in handy is we actually just draw little arrows sideways from this. And this is our periodic trend. Let's just do carbon, for instance. Carbon has 6 electrons. So therefore, we would have to fill up each orbital. Let's start with 1, since this is where our first one is. So 1s has 1 orbital. And how many electrons can go in each orbital? That's right, 2. So we put 2 of our electrons there. What's next, guys? That's right, 2s. 2s. And we can put 2 electrons there because, and what do we have left? We have 2 electrons. After using these 4, we only have 2 left in our carbon. So the next orbital would be our 2p. So 1, 2, and 3. This is all our 2p. So we just put 1 and 1. Okay, so that's our orbital. And let's just use helium, for instance. If we used helium, it would only have a 1s because it only has 2 electrons, and it has a very happy, safe orbital that doesn't want to bond. Fluorine, on the other hand, has 9 electrons. Let's put fluorine down. Let's move it up a little bit. Fluorine has 9 electrons. Okay, so where would we begin with this? Of course, our 1s, which would have 2 electrons. Our 2s has 2 electrons. And then our 2p. Okay? And we count down. We only have 5 electrons left. So, as we done before, we put 1 in each orbital. First, 1, 2, 3. So how many do we have left? 2 more electrons. So we go back and place these 2 over and over. And there's this one empty spot, 1 electron that's willing to bond. And if we put this electron there, we would have the stable conformation of neon. Let's put this in red. And that's why fluorine always wants to gain an electron, because it will have a perfect little full orbital. Okay, and this was Maria with orbitals.